Hi, this is Nathan Tintle. In this Learning Goal video, we're going to talk about how to implement the 3S strategy using the Can Dolphins Communicate example from the Introduction to Statistical Investigations textbook. The 3S strategy is a strategy statisticians use to measure strength of evidence. The 3 S's are statistic, simulate, and strength of evidence. The statistic is a number that's computed from the observed sample data. The simulation is the by chance alone explanation for the data. We repeatedly simulate values of the statistic that could have happened if the chance model was true. And finally, strength of evidence. We compare the outcomes of the simulation to the statistic. We ask ourselves, is the statistic the kind of thing that typically happens when the simulation is true? Or is the statistic something that is unlikely to occur if the simulation model is true? That is, if the by chance alone explanation is true. If the observed statistic is unlikely to occur by chance alone, then we can reject the by chance alone explanation and say we have evidence that that chance model is incorrect. On the other hand, if the statistic is one that often or typically happens when the chance model is true, then we say that the chance model is one plausible or believable explanation for the observed data. Let's apply the 3S strategy to the Doris and Buzz study. First, the statistic. In the Doris and Buzz study, the statistic is 15. That's the number of times Buzz pushed the correct lever in 16 attempts. The second S, simulate. In the Doris and Buzz study, the simulation involves flipping coins. First, we flip a coin 16 times, keeping track of how many heads we get. Then we repeat this process many, many times, generating a whole distribution of could-have-been statistics. That is, values for how often Buzz would have pushed the correct lever if, in fact, he was just guessing. To assess the strength of evidence, we take those many, many repetitions of the chance model. In this case, the dot plot you see here is 1,000 different sets of 16 button pushes. Each time, Buzz is merely guessing which lever is correct. And what we see is that out of all of these simulations, in fact, none of the time did we get a number as big as 15. From this, what can we conclude? Well, we can conclude that what happened in the study, that is Buzz pushing the correct lever 15 out of 16 times, is quite unlikely to occur just by chance, that is, if Buzz is just guessing. A few words of caution. First, the statistic is a single number that we observe on the sample data. Some students remember statistic by remembering that it's a measurement on the sample. Both of those words start with the letter S. Second, the simulation should match the just guessing explanation, or the chance model. Third, when we assess evidence, what we're looking at is evidence against the simulation or the chance model being true. A related point is you can't prove that the simulation model is correct, only that the simulation model is one reasonable or plausible explanation for the data.